There we go. All right. Welcome to week 2. Well, Quentin, I have not manually graded all of the first quizzes yet. So even if you did poorly, it counts towards your homework grade and not towards like a test grade. So doing poorly on a quiz or two is not going to completely sink you. So it's kind of just a test just to see, like a gauge to see, are we getting it? Are we understanding it? I should have them, all the quizzes, the manual parts graded tomorrow. I will start on the labs, but the labs take me a little bit more time. So please do not count on the labs being all graded by tomorrow. Usually give me till Friday. Every once in a while, something comes up, something crazy, weird comes up, and it takes me longer, but usually by Friday. Oh, I see. Okay. So, yeah, so almost every quiz, you're going to be asked a question regarding like the definitions. I try to give you a hint about which definitions they will be during the class. I try to do that. It does not always like actually resonate that that's what I'm saying, but I'm not going to say, hey, this is going to be on the quiz. I try to just say, hey, you might want to know this. This could come up later. So I try to kind of give you hints about that. And I also want you to know, I put this in an email and I think I mentioned it in the discussions, and maybe even in the welcome video, but realize that when you submit your lab, it is going to show graded with a 0. Same thing if you submit your hand-in homework, which we have hand-in homework coming up soon. So when you do hand-in homework work or a lab, it's going to show graded 0. And once I grade it, it will actually have a score. I always give feedback on hand-in homework and on labs if I take any points off at all. If you get a perfect score, I'm not going to leave you any feedback. There's no point in even looking for it. On the quizzes, on the manually graded parts, if I take points off on the manually graded parts, I will also give you feedback. You won't be able to see that until after the due date. You can't go back into the quiz until after it's been due, after it's closed for working on, but then you should be able to go back into it. I had something else, but it is gone. So just try not to freak out when you have zeros on your labs or on your hand-in homework once you hand them in. So try not to freak out. And if you do freak out, that's okay. I will try to unfreak you out. So today, it's a little bit longer class, but it still shouldn't be super long. On Thursday, we have parent-teacher conferences at the high school, so I will not be able to do a Zoom meeting. So we're doing 3.1 and 3.2 today. Thankfully, there's no lab this week, so this should be it, and you should be able to do all the homework for the week after today. So, but obviously, I'm still going to be available to answer questions and things like that. I just am not going to be on Zoom on Thursday. Okay. So first, we're going to talk about measures of central tendency. We're going to talk about mean, median, and mode, talk about basically average. Then lesson 3.2, we're going to talk about range, standard deviation, variance, and then we're going to talk about the empirical rule. Now, the most common things that we're going to use in this class throughout the entire term are going to be the mean, the standard deviation, and the empirical rule. Those are 3 probably biggest topics that they are going to be carried through the entire term. We will still occasionally talk about median, but not frequently. Whoa, I did it again. I hate when I do that. I bumped the cord and it just decides it doesn't want to work anymore. Gosh darn it. Okay. Let's see. There we go. Yay. Okay. Note to self, do not bump the cord. All right. So we're going to talk about all of that today. It actually, I said it was going to be a longer class, but the lesson 3.1 goes fairly quickly. But I am also going to show you a fancy calculator function. So hopefully you have your fancy schmancy calculator, TI 83 or 84 or whatever one you happen to have. I will show you some fancy calculator stuff. And I'm also going to jump into the homework and show you a calculator trick with the homework. So that is it right there. And I'm so sorry the first quiz tripped you all up a little bit. I know it's always hard that every time you have an assessment in a new class, any kind of assessment, you don't know what to expect. So I anticipate the next one's going to look a lot better, but very low stakes. These quizzes are super low stakes. They're not going to affect your grade terribly. So messing up on the first one, it's not going to hurt too much. In fact, I have it on good authority that there's going to be an extra credit quiz near the end of the term. So it's basically, if you do the extra credit quiz, it's basically going to wipe this one out. So look forward to that. And let's go. Okay. So we're going to start here, 3.1. So measures of central tendency. So we talk about average a lot. We talk about things that are like average home prices, average miles per gallon. And I think we all just know how to calculate average. And we're like, oh, this is the way I'm going to average it. I'm just going to add them all up and divide by how many there are. And I call it good. But there's actually 3 different things that can be referred to as average, though the mean is the one that's like the usual. But there are actually 3 different ways that we measure the center of our data. So all of these are based on mean. Average household income, average American woman is 5'4" and weighs 142 pounds. According to Census Bureau, the average commute time to work is 25.4 minutes, miles per gallon of a Chevy Corvette, all of this stuff. So these are all averages. So mean is the one that we're going to deal with the most. I almost never say arithmetic in front of it unless I'm giving you a definition. I always just call it the mean. So the only difference between population mean and sample mean when you look at them is there's a symbol for difference of them. So our population mean is a parameter, which means it refers to the entire population. It's this symbol right here. It looks kind of like a U with a long tail. When I draw it, it looks almost more like an M. It is pronounced mu. So this is the symbol for the population mean. And when we're talking about a sample mean, when we're using sample data, which is a statistic, we will use this and we just call it X bar. So it literally is X with a bar over it. So we call it X bar. So mu for population, X bar for sample. And when I draw mu, it looks like this. And as the term goes on and on and on, it's going to look worse and worse. But that's what my mu looks like, which looks more like an M than a U, but it's just the way I draw it. Okay. The way we calculate the mean, it is the way that we have been calculating mean forever and ever. You add all of the values together. So however many data values there are, we add all of them together, and then you divide by how many there are. So like, for example, if I had 3 test scores, I had a test score of 92 and one of 98 and one of 85, and I wanted to find their average, I would add them all together and then I would divide by 3. This is how we calculate the mean. So when we are using mean, we generally round it to 1 more decimal place than our raw value. So for example, take a look at my raw data right here. I had 3 test scores. I would round it to the 10th place because my test scores were whole numbers. So if it's whole numbers, you would round to the 10th place. If all their numbers were to the 10ths, you'd round to the hundredths, et cetera, et cetera. So generally 1 more decimal than your raw data. It's just kind of a rule of thumb, and people don't always follow it. It's just generally what we do. Okay. So let's calculate the population mean of this data. So what this data is the travel times and work for all 7 employees of a startup web company. So all 7 employees, this is their travel time to work. So I would just add all these numbers together. I'm just going to put pluses between them. So add all of these numbers together, my fancy schmancy calculator. 23 plus 36 plus 23 plus 18, 5 plus 26 plus 43. Add all those together. Adding them all together gives me 174. So 174 divided by 7 is about 24.9. So the average time it takes the people in this company to get to work would be 24.9 minutes. So I'm going to take a sample of 3 of these employees, and we're going to say it's random. I'll show you how to do a random sample in your calculator, but I don't know that you're going to be required to get a random sample in your homework at all, but I want to kind of show you how to get a random sample in your calculator. So I'm just going to randomly choose 3 of these. I'm going to do 36 plus 23 plus 43. And it wasn't really random because actually there's nothing that's truly random. Even your calculator's numbers are not truly random. So 102 divided by 3 is 34. So with a sample, obviously it's going to be somewhat different because it's not using the whole population. So when you have a lot of samples, it's good. So so the lowercase n is your sample size. If it's an uppercase N, it is your population size. So right now my population is 7, but my sample was 3. Good question, Jennifer. So lowercase n is almost always the sample. Uppercase N is almost always the population. I say almost because we don't deal in absolutes. So I'm going to show you how to get a random sample on your computer or on your calculator. That's not where I want to be. Let's go here. All right. So here's my fancy schmancy calculator. Now, the calculator says, I mean, it's choosing random, but it isn't really random because it uses an algorithm. So basically there's no way to truly choose a random sample. Nothing in this world is truly random, in my opinion, except for whether or not I say, yes, I want a receipt when I go to McDonald's. But otherwise, there's nothing really random. But your calculator does a pretty good job of pretending it's random. So if you hit this math button right here, which is right under the green one, so hit math, if it will do its thing. Why are you not mathing? There we go. Maybe. Why is everything just got to be slow? I'm going to I think I might need to refresh my calculator. I'm going to refresh this guy. And it's not like I haven't even been on the computer today. We had our final mathletes competition of the year. I'm the coach of the mathletes at the high school. And we had our final competition and my kids did really amazing. They are some great mathematicians. They did a great job. I think we didn't stay for the awards because we had to get back for baseball game. I think we might end up with a trophy and I'm so excited because our, what the heck? Because that doesn't happen a lot for this school. Yeah, they're a bunch of really great kids. We did lose one though. We're on the SOU campus and we lost one today. I lose one every year. I think I'm going to start having a poll at the beginning of the year of who it is we're going to lose. We got him back, but we did lose him. He just got lost on campus. He went to get food and he got lost. It was kind of funny. Oh, that's not the right thing. Doggone it. Okay. One more time. See, I'm just talking away about nothing, trying to get my calculator to work. Okay, let's get this done. Everything's just moving slow today. Wasting like 3 minutes of class. And the great thing about my mathletes team is next year is going to be even better because most of my students are juniors on my team. So next year we're going to do even better. I think I'm only losing 4 members of the team that are seniors. So next year it's going to be absolutely amazing. Okay, here's my calculator. Let's see if it does its thing. Oh, look at that. Okay, I hit the math button and it brought me here. Go over to PROB. So you're going to use this round thing right here with the arrows. Going to go to the right until your PROB is highlighted. So math arrow over to PROB, and we want number 8, which is rand int no repeat, which is random integer, no repeat. So it's not going to repeat the same number. So that's where we're going, arrow down until you get there, or you can hit the number 8 on your calculator. So our lower value, so I have here 7 employees, and I'm just going to number them 1 through 7. So my lowest number would be 1, and my upper number is 7, because I'm going to choose employees. One of the employees, you don't have that option? Is it a TI-84? Or is it something?
Okay, yeah, it is a TI-84. I got it. I just had to move my cursor over to the right.
Okay. Okay. So I'm choosing 3 of them. TI-83, it should be the same thing. Just a second, let me grab mine. Hiding over here. It was hiding over here. Somewhere. 1 second. Ah, found it. Okay, let me see if TI-83. So math. It's still there. It's not 8 though. You just have random integer. So you may end up with repeats, and you might just have to do it more than once. So yeah, you don't have the no repeat. You just have random normal and random bin. So if you're on the TI-83, yeah, just use the random integer. So I'll show you, I don't have the, so your random integer for the, so you would just put your lower, you'd put 1, 7, 3, and then close your parentheses, and it'll give you 3 numbers for the TI-83. Or if you don't have these. If you don't have these options, and it shows up, I'll put it, let me go back to the other screen. If it shows up just like this, like rand int like this, or rand int no repeat this, you're just going to put 1, 7, 3. That means lower 1, upper 7, choose 3. That's what you're doing. So if you don't have those options, that's what's going on. So you would just do 1, 7, 3, and then close your parentheses. And I'm going to go here and paste, and then hit enter, and I have 3 numbers. So if it gives you, if you don't have the no repeat and it gives you a repeat, then just, okay, I'll get you there again. Okay, let's start over. Math, this math button is right underneath the alpha button right here. Hit math, and then arrow over to prob. This round thing here has arrows, arrow to the right over to prob. And then if you don't have number 8, then you're going to have to use rand int. And then if you get repeats, just run it again and choose the first 3. The first 3 numbers, don't repeat the numbers that you use. But I'm going to go to rand int no repeat because I have it. Hit enter. And then it's 1, 7, and 3 because I want to choose 3. Then hit enter. So if it shows up just like this, see, notice how it pastes it in here. This is how you would type it in if you don't have those options. You would just type 1, 7, 3, and then close your parentheses. Don't put spaces or anything in there. And then hit enter, and I have 3, 6, and 1. You get an error. I'm not sure what you're doing. What are you using, rand int or rand?
I think I figured it out for the ones that are getting the error.
Okay.
If you hit rand int instead of rand int no repeat, and you put in the 1, 7, 3, it gives you 3 random numbers.
So try that.
So do the one without the no repeat. It gave me 2, 1, 1, so I don't know, are they allowed?
So
that's the thing, is that it
since
did
one's
repeat.
repeated, I would try it one more time, and it'll give you, I mean, even if it repeats some of them, just choose the first 3 that are unique. So just run it again.
Yeah.
And of the 6 that you have, choose the first 3 that are unique.
Okay. Thank you.
Yes.
For some reason on my calculator, it just automatically takes me to rand. There's no rand int option that I see. I might be doing something wrong. I'll look into it a little bit more later.
Okay, so I don't know what happens on Rand. We can look. Let me see what happens on Rand. I don't know. Rand? And this might give me an error because I don't know what this even does. Oops, I want 173. Let's go back to Rand. Okay, this just gives me any random decimal. So that's not going to help us at all. It's just a random anything. That's what Rand does. So you don't have any other options. What calculator do you have?
I have the TI-84, but it, like I said, it just automatically takes me to rand. When I do all the steps, it doesn't give me an option to choose rand in or any other, just
So when you
takes me
click on
automatic.
prob, is there no list under it when you click on prob?
Let me double check here. No, I'm just hitting enter. Is that not the button to press on that?
So when you're on prob, don't hit enter, just arrow over to prob,
Oh, okay.
and then it should just be a list under it. See, when
Oh,
I arrowed
Yep,
it,
I gotcha.
okay, are we good?
We're good. Sorry.
Okay. Okay, so we may need to, Kia, if you can send me a picture, I don't know if a picture of what you're putting in, like maybe this, what you have right before you hit enter for the error. I can talk about it after, I can look at it after class and maybe I can help you troubleshoot. So if you can just take a picture of what's in your calculator right before you hit enter. And we're gonna move on. Okay, so I did my random no repeat. I'm gonna go back there because I'm just gonna get out of here. So my three numbers that it gave me are way up here. Somewhere way up here. So the numbers it gave me were 361. So I'm gonna go back to here. So if I was gonna randomly get the average, get a sample mean, I would choose number 3, number 6, and number 1. This is as random as we're going to get. And then I would just add those 3 up and divide by 3. That's all I was getting at, but it's good to know how to get random numbers out of your calculator. I do it all the time for things like, I know this is really weird, but like if I do, occasionally I will choose a random person to receive a free gift if I'm doing a drawing or something like that, because I sometimes give away my crochet stuff. So if I'm doing a drawing, I can use my calculator to get a random number and like choose that comment. And it's just super useful. Or if I needed a random sample of something, it works out really nicely. My students at the high school use it when they're determining which students they're going to poll for whatever project they're doing in class. So it's a useful tool. It's nice to know it's there. And hopefully we'll figure out those are getting error messages. All right, let's move on. Okay, so here is a list of data, and we are going to calculate the mean. So on number 1, so in your calculator, put all 10 of these in here and then divide by 10. So get all 10 of these and go ahead and divide and calculate the mean. You just add them all together and then divide by 10. So this is going to be the mu because it is the population. There are 10 students in this class. It is a population. Did we get 79 as our mean score? Did we all get there? That's what I got. All right. So if you can make your calculator work, if you can't, you can just randomly choose one, pretend they're random, choose 4 numbers randomly. If your calculator's not working, then just choose them, like use your own randomness. Go ahead and pick 4 numbers. I'm going to use randint no repeat with 1 through 10 and choose 4. Got. I'm not going to make you get a second sample. Just do the 1. Those aren't the numbers I want to add. What in the heck am I doing? I don't know. Okay, my number 10 is 88. Uh-oh. I lost the numbers I had, but that's okay. I got new numbers. Okay, there we go. I got 87.3. What sample mean did you get? This is my X bar. Anyone else get a different X bar? Either say it or type it, I don't care. Got 78. Okay. Get another one. Another 74.5. We got 2 74.5s. Oh, 79.5. Okay, we have okay, I see. Well, we've got, so you notice that they're all different and none of them are exactly the population, but they all kind of are a little bit below or a little bit above. So obviously the population mean is the best, but all of these sample means are kind of close and they kind of give us an idea, but obviously population mean, if you can do it, do population. So on your hand-in homework, the hand-in homework that you are going to be doing, I believe it's for this week, it asks you to find the sample mean. Do not choose a sample. Use those numbers, but your symbol, your X bar will be, you'll use that instead of mean. But you're going to use all the numbers. Don't take a sample of them. Use all those numbers. I'm giving you a sample. So I think there's like 7 numbers there or something. Do not take a sample of those numbers. Use all those numbers, but they are a sample, if that makes sense. Okay, moving on. Questions so far? Are we doing okay? Other than the word calculator issues? Okay, the median. So the median is super useful when we have some data that is skewed. So if you have like some crazy outliers or you have data that is skewed, a lot of times we'll use the median. So what the median is, it's just the middle number. So you arrange your data from smallest to largest, and then you just find the middle number, and that will be your median. They use median a lot for home prices because if you have a super expensive home or a foreclosure included in the home prices, it's going to drag the mean with it. It's going to drag it down or drag it up. So we use the median home prices to say this is the middle of the road home prices. And a lot of times people will use the mean when they should use the median if they're trying to be a little bit dishonest. They're trying to trick people. Like, for example, one of the things I've noticed a lot is people will say the average educator salary in Oregon is $85,000 a year, and they're trying to say we make a lot of money. However, they're using average and they're including like administrators in there. And they're including teachers in there that have been teaching for 30 years. Administrators start at just under 6 figures. So they'll include those and just average them when there are these crazy outliers. If you were going to look at the median, I'm guessing the median teacher salary in Oregon would probably be around $50,000. That would probably be close. I don't know for sure, but my guess is that's about where it would be. So notice the huge difference because they use the mean instead of the median. So it's really good idea to like pay attention or to know or understand what they're using, because if there's any outliers, the median drag or the mean gets dragged that direction. So let's take a look at calculating the median. So once again, we have the travel times of 7 employees of a startup company. I'm going to change this to see if I could do single page at a time. There we go. Okay. So what I'm going to do is I'm going to put these in order, smallest to largest. And I'm really bad at this. I'm letting you know right now. I'm really bad. I frequently miss things. They should pay teachers more. You are right. I think that right there is the solution. I would love to get paid more. Not that I don't love teaching at RCC, but it would be nice to have just one job. All right. So I'm going to start with 5. I'm going to cross them out as I go because otherwise I am really going to mess up. 23, 23, 26, 36, and 43. Since this is an odd number, it makes it super easy because it's just the middle number. Our median is right here. It is just that middle number. So that's all the median is. And the way that I remember median is that you think about that there's a median in the center of the road that separates the flow of traffic. The median is in the center, and the median is the center of your data. If that doesn't help you remember it, you figure out your own mnemonic device, but that's how I remember it. So there you go. Questions about median? Okay. Moving on. So a new employee starts working here. They have a 70-minute commute. So once again, we're going to find the median, but this time we have an even number of data values. So it's going to change things just a little bit. Man, that was ugly. That's an ugly 23. And then I'm running out of room. Okay. So when you have an even number of data values, you need to find the value in between the middle two. So I need to find the value in between here. So I would just average those two. So take 23 plus 26 and divide it by 2. Most of the time you can just look at it and you can see what the middle value is, because sometimes it's really easy to see which number is halfway between those two. So our median is 24.5. So this right here is the median. So it is still the very center, but this is not one of our data values, but it is still just the very center. So it's halfway between 23 and 26. That would be our median. So this is only when you have an even number of values. Questions? All right. Okay. So in the 1970s, we took a random sample of songs and their length in seconds, and we're going to find the median length of songs. So we have to put these in order from smallest to largest. So I would like this. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them here. I would like you to try to find the median. So put them in order from smallest to largest, then find that middle value. So I'm going to wait a minute and then I'm going to work quietly in the background. So if you get stuck, look up. Otherwise, just ignore me. Then you can look up and see if our answers match. Oh, see, I did it already. So bad at this. All right. Give you another moment to get her done, especially if anybody else struggled with getting them in order like I did. You did it? Good. Yay, look at y'all. You're getting the answer. Woohoo! You found the median. Perfect. So the median song length would be 217 seconds. Questions on median? Okay. Move over. Pink Floyd scoffs and distance. It's funny. Okay, but Pink Floyd will never be average, so it's okay. We don't want them to be median because they'll never be average. See, some of my earliest memories are singing Pink Floyd songs in my house, so there we go. All right. So there are 10 here. So let's do the test scores. Let's try when we have an even number. See if we can get these in order. Almost messed that one up. Wow. Okay. You're distracting me, Quentin. Stop it. Kidding. No, it's good. You're fine. Yay. Good job, Jennifer. You got it. So my median is 79.5. I see that couple of you already posted in there, Jennifer and Alice. Good job. Everybody else that got 79.5, pat yourself on the back. Good job. You've got median down. Woohoo. All right. We're going to move to the super, super difficult mode. Not difficult at all. Not really difficult at all. Easiest of all of them. And there's some really catchy little ditties on YouTube that will, if you can't remember mean, median, and mode, catchy little ditties on YouTube. Little cartoon videos with songs attached to them. Very catchy. And you'll be singing them for days. It's a life-changing experience. Don't do it. Don't do it. Okay. You had a mode problem? Okay. So before we jump into mode, we're going to talk about the relationship between mean and median. So really important here is with our test scores. Our mean was 79 and our median is 79.5. Those are almost the same number. They're so close to each other. So this is a good thing. This means that our data is symmetric. That means that it's basically like a bell curve. So if your mean is less than your median, then it is skewed to the left. If my mean is greater than my median, then it is skewed to the right. And if they're roughly the same, then it is symmetric. This is a good page to bookmark. So I personally, when I was in college, when I had a big stack of notes, which even if you print these 3 to a page, there's still going to be a decent stack of notes that you're going to have. I would put a Post-it note on things that I want to be able to quickly reference. You're going to want to put a Post-it note on this because you will want to be able to quickly reference this. On the next lab that we do, I believe it's on lab 2, you're going to be asked a question about mean and median, and you're going to have to talk about the how it's skewed based on the relationship between mean and median. So you will want to remember this. So if its mean is less than median, it is skewed left. If mean is greater than median, it is skewed right. Otherwise, it's roughly symmetric. So a little Post-it note, or just, maybe dog ear, even though I'm not normally an advocate for dog ears, but this isn't a book, so it's okay. So because you will want to remember this. Okay, moving on. I am not going to ask you to put these in your calculator or in your head or write them down. I put them in order, though. That was very kind of me. I put these in order. We are going to find the mean and the median of these values, and I believe they're on the next page. And I put them in order. Our smallest home value set was 79,995. Our largest is 349,900. There's a huge difference between those. So we're probably going to end up with some skew issues because of it. So we're going to find the mean and the median, and then we're going to talk about the shape of the distribution. So the mean asking price is 168,320. My median, sorry, I'm going to erase this. I don't want that on there. The median is 148,700. I'm going to just underline them. Sorry, I don't have a pen on. So the mean is 168,320 and the median is 148,700. So it's going to be skewed. So my mean is greater than my median. So let's go back here. If the mean is greater than the median, it is skewed right. So my mean's greater than my median. Go back here. We are skewed right. It's as simple as that. I frequently forget which one, and I have to start playing with it and saying, okay, so if my mean is over here, my median is here, our median means that all of the data is pulled this way. I have to play with it in my head, but if you're going to be able to use your notes on tests, so you should be fine. I don't think I ask a question like that on the test, but I mean, the test changes every time, so who even knows what's going to happen? But it's a good, important thing to know. Does this make sense? Questions? Okay. Moving on. Now we're going to do, oh, here's a nice histogram. It shows that it's skewed right. Nice, pretty histogram. I mean, it's not super pretty, but it's good enough. Notice, though, I have labels on my axes and a title on my thing. Don't forget, you need those things. You need labels. And notice that my lower, I don't know why there's no lower label on the first box, but each of the other ones has the lower end labeled. Okay. Okay, so we're going to talk about babies, and we're going to talk about which measure of central tendency best describes the average birth weight. I am telling you, though, I removed all of the sad baby problems from this class. There's a lot of them in the book. I don't do sad baby problems. I only do happy baby problems. So, because you know, the people who deal with statistics the most are ones that do things like car crashes and stuff like that. So we only do happy baby problems. So here's the birth weight of 50 randomly sampled babies. We're going to look at the mean and the median. We're going to talk about the skew, whether or not there's a skew, and which measure of central tendency we should use. So let's take a look at this. So my birth weight of my babies, they're really close. I don't have the actual values because I forgot to write them down. But take a look. They're both right there in the middle. The median is very slightly less than my mean, but very slightly. This is mostly, oh, this is an eraser, but that looks kind of cool. There's a very slight skew, but it is mostly symmetrical. Remember that we don't deal in absolutes. You were 10.2 pounds. Wow. I feel bad for your mom. She deserves huge birthday or Mother's Day presents every year for her the rest of her life. My biggest baby was 8'2", and I thought he was big. He's right here. There he is. That was my biggest baby. My goodness, your mother is like, you know, should be royalty. Anyway, all right. Well fed was a happy problem. Yes, definitely. Okay. So when the mean and the median are super close, when we have a nice symmetrical, not skewed, we use the mean. So I'm going to write that right here, except for my pen keeps turning to an eraser all by itself. Not skewed. Use mean. Skewed. Use median. I'm going to give you, you're going to have a whole page about it in a minute. Okay. Not skewed, use mean. Skewed, use median. This is a standard now. Once again, we don't say this is the way it is 100% of the time, but mostly. You're not going to go wrong by following this. But we don't deal in absolutes, so every once in a while there's an exception. But in this case, we're just going to say if it's not skewed, we're going to use our mean. If it's skewed, we're going to use our median. So there we go. You will be asked a question about that, but which one to use based on some data that you have. So, and I think it's in the homework. There could potentially have one on the test. I haven't decided yet. We'll see. Okay, the mode. This is the one that I use the least, but it is there. So all the mode is which one occurs most frequently. Which one happens the most? Now we could have no mode and you can have one mode. You can have more than one mode. I like the word for two modes. It's bimodal. I don't think there's a word trimodal, but I like the word bimodal like this. Write it. Bimodal. It's a good word. I like to say it. But if there's no observation that occurs more than once, you can say it's no mode. If there's a most frequent, you say what the mode is. It's one mode, and that's it. All right. So we're going to do an example. So this is the vice presidents through Mike Pence. I could have added Kamala Harris on here, but my table is completely full, and I didn't want to add one little box down here, which I could have, but I didn't want to just add one more box down here, so I didn't. So we're just through Mike Pence, and we're going to look at where they were born. So I made a frequency table because it's easier to read once it's been organized in a frequency table. So you can see that New York has had eight vice presidents born in New York. I have it on the next screen. 8 vice presidents born in New York. Therefore, the mode is New York. That's really all it is. Which thing occurs more than once? Now, let's say the next 7 vice presidents, let's just say that the next 7 vice presidents are born in Iowa. Somehow we ended up with that happening. Therefore, let's say we end up with 8 in Iowa. So now I have 2 of them that have the most. This would be bimodal. So my modes would be both New York and Iowa if the next 7 vice presidents were born in Iowa, which is just so likely to happen. Nothing against Iowa, but it just doesn't seem like a normal place for a vice president to be born. Which is probably why there's only one of them. I wonder who that was. Now I need to know. Who was born in Iowa? It was Henry Wallace. I don't even know who that is. But Henry Wallace was born in Iowa. There we go. Now we know, have one more piece of information, brand new. Okay. Here is the table that is useful, super useful table that tells you which to use and how to calculate them. So the mean, when our data is quantitative and our frequency distribution is roughly symmetric, we will use the mean. Sometimes you'd say, I don't know why center of gravity is the thing that they put there, but apparently it is. And the mean is our more common word for average. This symbol right here is a capital sigma, and this just means add them all up. That's a capital sigma, and it just means add them all up. That's all it means. And then median, so it divides the bottom 50% from the top 50%. And if you have quantitative data and we're skewed left or right, then you will use the median. For the mode is the most frequently observed thing, most frequent observation. You can use mode if you have categorical data, and it's just the thing that shows up most. Like, for example, if you were counting M&Ms, the color that shows up most would be the mode. And there's really no other way to find center other than just use the mode. So there you go. Questions about this? All right, moving on. I think, look, we're in section 3.2. I know it's 6:30 already. You guys are doing great. Before we start 6.2, do you all need a break? This all makes sense? Good. If you all need a break, we could take 5 minutes right here so you can get water or a bathroom. If not, if nobody says they need a break, we're going to keep going. If somebody says they need a break, even one person, it's fine. We'll take a break. Let me know. Going once? Going twice? All right, no break. Y'all are such troopers. Thank you. Okay. I don't, it didn't matter to me either way. So range. Range is just the largest data value minus the smallest data value. So that's all it is. You take the largest data value and you subtract the smallest data value. That's it. The range, it tells you how many is there. That's all the range is. Or you can, or it's a piece of land that you put your home and then sing home on the range. Sorry. Okay. So see, Quentin, I beat you to it. So the range of this data is I would take the largest, which is 43, and I'm going to subtract the smallest from it. So you just do 43 minus 5, and that is 38. So my range is 38. 38 minutes separates the smallest data value from the largest data value. That's it. There's nothing fancy. This is the range. Boom. The most complicated thing we do today is going to be something called standard deviation, and we're going to do it in a minute. I'm going to show you how to hand calculate it. Then I'm going to show you fancy schmancy calculator stuff. So this is crazy looking, but I'm going to explain what it is. So standard deviation, so it tells you how spread out the numbers are. So basically it is the average distance each of the values are from the mean. So if I took all of the values and I figured out the average distance they are from the mean, that's called the standard deviation. So our population standard deviation, this is a lowercase sigma. When I draw it, it looks like that. It looks nothing like the original one, just letting you know what kind of artistry you can expect. So what we do, and you are going to have to do this by hand, well, once in this lesson, and then twice, and then never again by hand, unless you choose to. So You take each data value, you subtract the mean from that data value, and then you square what you get. Then you do that with the next data value. Yes, Greek in cursive, perfect. You take the next data value and you take that, subtract the mean from that one, then you square it. You do that with each data value, then you add all of those together and you divide them by the total population number. After that, take the square root, and that is the standard deviation. We're going to do one by hand, don't worry. So this is the population though. Sample standard deviation is calculated a little bit different. But so if you have a sigma, this is the population standard deviation, this lowercase sigma. Okay. We're going to do one together and we're going to be mathing it. It's kind of a bit of math here. The first thing we're going to do is we're going to try to remember what the travel times average was. Does anybody happen to remember what the average was for the travel times? Our mean? And I could calculate it again, but if someone has that value, that'd be really cool. Let's go back. I want to go back. Is it 24 point? Yep, 24.9. Okay. Our mean, our mu was 24.9. Thank you. So I'm going to take each of these data values. I'm going to subtract the mean from them, and then I'm going to square it. So this is what it's going to look like. 23 minus 24.9 squared. I have my little calculator here. Uh-oh. Crazy, crazy me. I did something wonky with my calculator. Sorry about that. So 23 minus 24.9. Then I'm going to square that number. I have 3.61. We're going to do that with each of these values. 36 minus 24.9 squared. $123.21. Thankfully, I have the second number is the same as, or this number right here is the same as the first one. I don't have to calculate that. 23, whoops, 18. 18 minus 24.9 squared. Whoa, I did something weird. 18 minus 24.9. Sometimes even with a calculator, I can't math. Then 5 minus 24.9 squared. $396.01. We're almost there. 26 minus 24.9 squared. Did I mess that other one up? Nope, it's good. 26 minus 24.9 squared. This one's 1.21. That one's kind of nice. And then lastly, 43 minus 24.9 squared. Look how that all fit in the box. It's almost like I planned it that way. 327. Okay. So I calculated, took each value, subtracted the mean, and then squared it. Next, add all of these values together and then divide by the number of data values I have. I have 7 data values. So I'm going to add all of these together. 123.21 plus 3.6 plus 47.6 plus 396.01 plus 1.21 plus 327.61. Enter. Okay, I got 902.86, and I'm going to divide that by 7. I got, so this right here gives me 128.98. If anybody's mathing along with me, please make sure to let me know if I make a mistake. Okay, last but not least, take the square root of this. So I want the square root 128.98. It's a really ugly 9, but trust me, it's a 9. So to take the square root on your calculator, you have to hit the second button and then the x squared button. So it's second There's the blue button and then x squared. And you could take the square root of that value. So my standard deviation, my sigma, is approximately 11.36. So that is the standard deviation. It is a big pain in the rear to do it by hand. Thankfully, we know how to do it in the calculator, and I'm going to show you how to do it in the calculator. But first, we're going to do sample standard deviation, and then we'll do calculator. Questions about this? All righty.
I have a question.
Yes.
Can you just explain a little bit? I'm sort of confused on what the standard deviation means as far as it's just like an average between each value, technically.
Yeah, so it basically tells you how spread out your data is. Because it tells you the average distance each value is from mean. So it's basically,
Okay.
yeah, taking the distance between all of them and averaging how far they are from mean. The reason we square it is because we need to get rid of the negatives. And that's basically what's happening because we square it and then we square root it later. So the
Right.
squaring is just basically getting rid of all the negatives.
Okay. Thank you.
And yeah, because standard deviation is a distance. So distances aren't negative. So we want it to be
Mhm. Okay.
good question. Thank you. Okay, let's talk sample standard deviation. So this tells you to calculate them all. With the squiggle means approximately. I'm never going to get mad at you for not using the squiggle, but the squiggle makes me happy. So the squiggle just means approximately. I like the squiggle. So do you guys feel we need to calculate another one of these by hand, or do you feel looking in your notes right here is going to be adequate? Because we can do the next one by hand. You're good? Okay. All right. So what I want to do, we're going to talk about sample standard deviation. We're going to do one sample by hand, and then I'm going to show you the calculator. So sample standard deviation, the symbol is just a lowercase s. What I don't understand with stats is most of the time it chooses things to be upper and lowercase that don't look very much different than each other. It likes to use lowercase and uppercase s and then lower and uppercase x. They're two things that don't look much different than each other, but they use them anyway. So sorry. Regardless, lowercase s is sample standard deviation. It is exactly the same as population standard deviation, but we divide by n minus 1. So you divide by 1 less than the sample size. So if I have a sample size of 10, we'll divide by 9. Sample size of 6, you divide by 5. We call this degrees of freedom, but we're not going to go into deeply what degrees of freedom means right now. What's the reasoning behind this? I've done a lot of Googling, finding the reason behind it. And the only thing that I've been able to conclude is it's because, remember back when we did the samples of the test scores and all of ours varied so much. Because there's that variability, we need to have our sample standard deviation be a little bit bigger to account for the variability in samples. Because samples vary so much from each other. We just need that little extra space there. So we divide by n minus 1. So when you're doing your hand in homework, make sure that when you're calculating the sample standard deviation, you divide by n minus 1. Otherwise, it's the same. Okay, moving on, we're going to do a sample. Thankfully, this is only 3 here. We're going to do a sample. We're going to calculate it the same way, but we're going to divide by n minus 1. So we're going to find the average of this sample. So I'm going to add these 3 values together and divide by 3. So I got 22.3 is my X bar. Remember, X bar is for sample mean. So let's take this sample standard deviation and find the value. So I do 5 minus 22.3 and then square it. That's 299.29. Take 26 minus 22.3 squared. Boy, this is really ugly writing. $13.69. The one class that's missing from teacher training programs is how to write on an iPad or a board nicely. They really should give us a class on that. We have 187.69. All right. So now I'm just going to add these three numbers together. 0.29 plus 13.69 plus 87.69, enter. Adding those together, I got 500.67. So remember, we divide by one, like n minus 1. So we have 3 values here. I'm going to divide by 2. 250. 335. I can't write that off. We're just going to call that 34 then, because I ran out of room. Okay. So last piece, don't forget the taking the square root. That's the very last piece. So second x squared, take the square root. I got my s is approximately 15. Whoa, that's not the right number. 15.82. So my standard deviation here for my sample standard deviation is 15.82. Notice it is significantly larger than our standard deviation back here, our population standard deviation. Number one, it's because it's a sample. Number two, it's because we divided by n minus 1. Do y'all like to see the fancy schmancy calculator function? Okay. We're really almost done. We don't have a ton left. Okay. We're going to go to our calculators, and even your TI-83 does have this. So you should be fine on your TI-83. Yes, n minus 1 made it 2 because my n, yeah, that's a good question, Quentin. So my sample size is 3. So n minus 1, n is 3, so n minus 1 would be 2. So if I had a sample size of 12, my n minus 1 would be 11. So make sure that you're using 1 minus the sample size. Good. Okay, I'm going to go to the calculator if I can find it. Right over here is my calculator. I need to get back out of this. I went weird places here and get out of here. I'm sure there's an easier way to do that. Okay, so this is probably going to be one of the more important places that you go in your calculator. So hopefully you all have your calculators handy. Click the STAT button right here. So right next to the circle is a button that says STAT. So click on that. And we want the first option. It's edit. This gives us lists of numbers or places to put lists of numbers. I really hope that your first one says L1. So if your first one does say L1, you're going to arrow up if you have data that's already in there. If there's data already in there, you're going to use the round arrows thing here and arrow up until the L1 is highlighted, then hit clear, enter. Do not hit delete. Hit clear, enter. So once again, go up and highlight the L1 and hit clear, enter. Whoa, that's not the enter button. Clear, enter. And that will erase everything in that list. Because if you hit delete, you will no longer have an L1 column, which I can fix, but we don't want to have to fix it. So now we are going to put the data values. We're gonna do, I think, let's do the test scores. So feel free to just copy what I'm putting in here. I'm going to put the test scores in here. 82, 77. So you just put it in there and hit the enter button. So just type in the number and hit the enter button. And just type in each number, just hit the enter button, and they will just each go in there. Go ahead and get all 10 values in there. Anyone need another moment? I'm gonna, where's my TI 83? Just to make sure, because I know that we have a TI 83 in the house. I'm gonna go in my TI 83 and I'm just gonna put some numbers in there. And they're not gonna be the right numbers, but I just want to make sure that I'm teaching you correctly that works with that. Okay. Now, once again, after all your numbers are in there, hit the stat button again. Notice up at the top, we have 3 options: edit, calc, tests. Arrow over to calc, don't hit enter. Arrow over to calc, and you want this first option. One var stats is one variable statistics. We have one variable and we are looking for one variable statistics, and then hit enter on that. And you should get this right here. Okay. Your first list, you want your list is L1. So if it does not say L1, you'll hit second number 1, because notice above the number 1 is a little blue L1. If you are on a TI 83 and you don't have these options, it'll just say one var stats on your screen, and just do L1 right next to it. So you would do second, then the number 1 right next to it. I'm leaving frequency list blank. Then I'm going to go down to calculate and hit enter. With your TI 83, if you just hit enter, you'll get all the numbers. Okay. Let me tell you what each of these boxes, each of these things mean. The first one is our X bar. The calculator always assumes we have a sample. So it doesn't give us a mu, it gives us an X bar. Doesn't matter, we calculate mean the same way no matter what. So our mean was 79. The one underneath of it just is all of them added together. And I don't know why we would ever need this, but this is the sum of all of the squares, all of them added together, each one squared. I don't know why we'd ever need that. SX is your sample standard deviation. Sigma X is your population standard deviation. The N tells me I have 10 data values. The minimum X tells me my minimum value. I'm going to ignore Q1 right now. We're going to talk about that next week. The median is right here, 79.5. I'm ignoring Q3. We talk about that next week. And our maximum is 94. So this gives us basically anything that we're going to need with this data. And it is so much quicker than doing it by hand. Please don't do it by hand unless I specifically tell you to, which will only be on your hand in homework. Other than that, I will never ask you to do it by hand. Please don't do it by hand. Questions before I move on? Okay. This is if you didn't write that down, does anybody need me to go through the steps one more time so you can write down which buttons to push? So I can do that. Okay. I'll do that. All right. So go to stat, hit stat. I mean, I prefer it handwritten, but if you type it, I mean, as long as you're showing your work, you can type it out. It doesn't really matter if your work is shown. I just feel typing it out is a lot more work, but if that's what you need to do, that's fine. Okay. So back to this, you hit stat, you want the first option, edit. If you have something in the box, arrow up to highlight L1 and hit clear, enter. I don't know if you needed those instructions, but whatever. I'm going to put in random stuff because I just erased everything. So I'm just going to put random stuff in here. Okay, oops, I'm doing some crazy stuff here. Okay, I just got some random numbers in there. Enter your data. You can just take a picture of it with your phone if you want, Alice. That works also. Or you can type it, it's fine. Just taking a picture with your phone works too. Okay, Now, after you enter your data values, hit stat again. Hit stat, arrow over to calc. So arrow over to calc. You want the first option, one var stats, which is one variable statistics. The first option. And hit enter. The list you want is L1. So to get L1, you would hit second and 1 if it's not already there. If you put your data in L2, you'd put second 2. If you put your data in L3, you'd hit second 3. You can see all the lists above from 1 to 6 right there. Leave the frequency list blank. We're going to use that in a minute, though. Leave that blank. Then you hit calculate. And bam, there it is. These numbers don't mean anything because they're completely random. But anyway, there you go. All right. Does anyone need any more explanation on what these numbers are before we move on? All right. Moving on over. Okay, where were we? Let's go back. Okay. When we have discrete data, and sometimes we use a histogram, we already kind of talked about this, so I'm going to leave that alone. Okay, let's talk about the standard deviations for McDonald's and Wendy's. And you will have at least one question on your homework that compares standard deviations, and you talk about what it means. So here's some data for samples of wait times at Wendy's and McDonald's. I don't know if they're drive-throughs or in person, and it doesn't really matter, but here's just some data. So here are the standard deviations for McDonald's and for Wendy's. The standard deviation for Wendy's is 0.738. For McDonald's is 1.265. So when you have a larger standard deviation, it's not as, you can't make a guess as well about what it's going to be. A smaller standard deviation means that most of the values are really close to the mean, so it's more predictable. So if I was going to like make an investment or something, having a more predictable outcome is a good thing. So if I went to Wendy's, I would be able to narrow down how long it's going to take a lot better than at McDonald's. So having a smaller standard deviation is good for being able to predict something or be able to like have reliability. So I would like to have the more reliable wait time. So small standard deviation means that the data values are closer than the mean. So my curve would probably look more like this. For McDonald's, my curve would probably look more like this because the data would be more spread out. That makes any sense. All right. Maybe. So I never, ever, ever in my life have ever used variance for anything. However, you will be asked for variance in at least one problem. I don't know why variance is so important to the writers of statistics textbooks, but it is. So all that variance is the square of the standard deviation, or it's right before you take the square root. So if you just take the square of the standard deviation, so you do sigma squared or S squared, then that is your variance. So just square that value and you have a variance. And I've never, ever, ever used it for anything except for answering questions in stats class. So there you go. There's my super important topic of the day, mode and variance, my important topics. I don't know what to use it for. So if I had, like, for example, let's go back here. Wait, way back. Okay. So we calculated a standard deviation. My variance, the variance is this number right here, this 250.34 before I took the square root. That's the variance. So I haven't taken the square root yet. That's the variance. Or if you go to McDonald's and Wendy's, if I did, I don't know what just happened to my screen. If I do 1 1.265 and I square that value. Let me see here. That's not a good calculator. 1.265 squared would equal 1.6. This right here is the variance. So I've never used it for anything other than answering questions in stats class. So if they ask you for the variance, just square the standard deviation. You're welcome. Happy to do it. Okay. There. Okay. This is probably one of the most important things we will learn. I don't want to get you, I don't want to make you feel like stressed out about this. The empirical rule is an estimate. And in your homework, on your hand, I know I keep talking about your hand in homework. The answers in the homework in my open math for 3.2 and in the hand in homework, I want you to use the empirical rule to answer the questions about what percent lies between what values. If you go into the tutoring center, which they are absolutely amazing, they're going to give you a fancy schmancy calculator function to calculate it. We don't want to use that yet. We want to use the estimates by the empirical rule. These are not exact values, but they're pretty darn close. So it's a really great like rule of thumb and a really great way to estimate the value of things. Anyway, so if I took the mean and I added the standard deviation to it and got a value, then I subtracted the standard deviation from the mean and got a value below the mean. In between those two values we found, 68% of our data lies there. 68% of our data is going to be found within one standard deviation of the mean. Remember I said standard deviation is a distance. So within one standard deviation of the mean, 68% of our data lies. 95% of our data is within two standard deviations of the mean. So that's 95% of our data. So I want to make a little note here, and I want you to write this down. Any value more than two standard deviations up from the mean is an outlier. We'll talk about outliers again later, but I want to add this in here right here. Standard deviations from the mean is an outlier. Just write that there. You'll refer back to it later, but just write it. I'm going to leave it there for a second. So if we were using sample data, we'd use X bar instead of mu, and we'd use S instead of sigma. But for right now, we're just going to use mu and sigma. I'm going to give you a second to finish writing that sentence. Anyone need another moment? Moving on. Okay. This is the beautiful drawing that you were going to draw no fewer than 3,487 times this term. This is a great place to put a Post-it note if you, or whatever you need to do to bookmark this page, because this is a thing of beauty. I draw it so frequently in my high school stats class. I will draw it frequently for you. It is a thing of beauty. So 68% of my data is within one standard deviation of the mean. 95% of my data is within two standard deviations of the mean. 99.7% of the data are within three standard deviations of the mean. So you have what's left over is 0.3%. So I have 0.15 at the bottom and 0.15 at the top. So anything that is greater than three standard deviations is in that little 0.15%. However, remember, anything outside of this area is an outlier. So all of this stuff, all the other stuff are outliers. This yellow area that I just highlighted, that is usual. That's not outliers. Anything outside of that's going to be an outlier. So this drawing, it splits it up kind of in half, because 68% of our data, we have 34% below the mean and 34% above the mean that are that middle 68%. Then this represents 13.5% right here on either side. That adds up to the 95. Then we've got our 2.35 right here and right here. That gets us to 99.7. And then we have our last little bit. So this drawing with these percents is pretty important. You're going to be asked questions. I didn't mean to erase all of that, but that is what it is. So you're going to be asked questions that are going to have you reference these percents and just add them together. Like, for example, if I said, okay, I have an example in a minute. Trying to make something up off on the spot sometimes hurts my brain. So you're going to draw this a lot. Okay, I'm going to move on. So I'm going to give you an example where we're using data, and you're going to have homework problems like this. The following data represent the serum HDL cholesterol of 54 female patients of a family doctor. I don't know what this means, and I'm sure it's just the cholesterol levels or whatever, but this is just a bunch of data. So I'm going to give you the population mean and the standard deviation, and we're going to do a nice pretty bell shape. I'm going to show you all of this, and then we're going to do some calculations. We only have 3 slides left, by the way. We are almost done. Okay, so here's my nice histogram. It is roughly, I thought that was a pen. This is roughly bell-shaped. I mean, there's a slight skew, but it is roughly bell-shaped. We're going to pretend it's bell-shaped because it is really close. And it's a little wonky, but it's roughly bell-shaped. My mean is 57.4, and my standard deviation is 11.7. I'm going to draw, I have a drawing of this on a bell curve, and we're going to see where all of the data lies. So hold on a second here. So here's my bell curve. So this right here is my mean. And then I added my standard deviation, which was what? 11.7. So I added 11.7. So I took my mean, and then I added 11.7, and I got this value right here. Then I added 11.7 again, and I got this value right here. Then once again added 11.7, and I got this value right here. So as you see, there's 1, 2, 3 standard deviations from the mean to get to this value here. There are 2 standard deviations from the mean to get this value, and 1 standard deviation from the mean to get this value. Going the other direction, I subtracted 11.7 to get this value, subtracted 11.7 again to get this one, subtracted it again to get that one. So that way I'm 3 standard deviations from the mean to the left. This is how we populate our empirical or our bell curve with all of our values so that we can use the empirical rule. Okay. So I know that the percentage of all patients who have serum HDL in this thing right here, between 34 and 69.1, we are going to estimate it with the empirical rule. I'm going to get my highlighter out again because I like the highlighter. I'm going to make it fatter. Okay. So I like my highlighter. So between 34 and 69.1, that is this area right here. Okay. So this area right here. So all I'm going to do is I'm going to add those percents together that fall in between those 2 values. So on my bell curve with my percents on there, just going to add 34% plus 34% plus 13.5%, which is, I know I could do this in my head, but just bear with me. So that's 81.5%. So I estimate that 81.5% of the women have their HDL serum HDL cholesterol between 34 and 69.1 based on the empirical rule. So remember, this is an estimate, but it's usually a pretty good estimate. So I'm going to go back to my data values back here, and I'm going to look at these 54 patients, and I'm going to go between 34 and 34 and 69.1, and I'm going to count them. So 40, 34, man, I just like lost my number. 34 and 69.1. I'm just going to count them. So I'm just going to circle them because it's easier that way. And it's probably going to be most of them. It might have been easier for me not to just circle the ones that were not. This is okay. It doesn't take that long. 34 and 69.1. Okay, so I didn't circle 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5, 6, 7, 8. So 48 out of 54. So I got 88.9. I mean, so it's a little bit off. I got 88.9 was the actual. It's a little bit off, but I mean, we were just an estimate. Oh, did I count them wrong? It was 9, not 8. 1, 2, 3, 4, 5, 6, 7. There were 9 of them. That would make a difference. So 45 divided by 54. Look at that. That's 83 point. This is why I keep you around. So it was 83.3. That is much closer. So 83.3 is pretty close to 81.5. So it's a nice estimate. So we are going to, until I teach you something different, use the empirical rule for these. If you go to the tutoring center and they try to help you by giving you a fancy calculator function, please let them know you need to use the empirical rule for these problems until I teach you something different. Because it is actually pretty important to memorize the empirical rule, or at least understand it well enough that you can read the table, because I'm not going to require you to, you get to use notes on your test, but being able to understand it is pretty good. I think I have one slide left. Look, it's a blank slide. Real quick though. Okay. So we're done with the PowerPoint, but I want to show you one problem first on the homework. And I know this was the homework I believe you already did, but I'm going to show it to you anyway. So I think it was 2.1. Is it? No, this is 3.1. You haven't done this yet. Okay. So real quick, this is a homework question, and this is the homework question I get the most questions on. So I get the most questions on this from students. So I wanted to show you this real quick. Now, I apologize in advance. This does not work. This calculator thing I'm going to show you does not work on the TI-83. TI-83 doesn't quite have this capability, but you still can do this problem. So this right here, it asks you to find the mean and the median. It's really important to notice that look at the frequencies. So I can't just take these test scores and add all of them together and divide by 3, 6, 8, because there are 4 people who scored 3. There are 3 people who scored 4, 3 people that scored 5. So you would need to look at the raw data. And so I would have, if I'm adding them all together, there's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 21 students here. So you're going to need to add up each of these 3s individually, each of these 4s individually, each of these 5s individually, and then divide by that many students. Yes, expand the graph. That's perfect, Alice. Yes, her son said your son's really smart. He said you need to expand the graph. You need to look at all of the raw value and not the scrunched value. However, because we're fancy like that, if you have, he's really smart. I need him in my AP stats class. Okay. Anyway, I'm going to show you on a calculator how to do this quickly. And once again, I apologize. It's not available on the TI-83, but I can show you for the TI-84. Okay. My TI-84, I'm going to go to the stat. We're going to go to the lists again. And once again, I'm going to clear enter. In the L1, I am going to put the test scores. 3, enter. 4, enter. 5. It's really great how all these test scores are completely in order. Whoops. 8, 9, 10. In the L2 column, you are going to put the frequency of each test score. How many times it shows up. And there might be a way to do this in TI 83, but I don't know. I only know how to do it in TI 84, so it probably works in like 89 and others, but I only know TI 84 on this. Okay, so my test scores are here. My frequency is here. Now we're going to once again go to stat, and you're going to go over to calc, and you want one variable statistics again. The only difference is this right here, the frequency list. We're going to tell it how frequently each one shows up by sending it to the frequency list. So I'm going to do second 2 to put L2 in there, and then go down to calculate, and it's going to give me the mean and the median based on the frequency that each one shows up. You already forgot where the list is? Hit stat, edit, and then the lists are right there. Yeah, stat, edit. And then go to to get to one variable statistics, it's stat, and then go over to calc, and it's your first option. And when you make sure that you only have a frequency list in here if you're using a frequency list, because when you come back here to do another problem, you definitely don't want that one in there. So make sure you delete it later if you're using it for something else later.
I have a question.
Yes.
When you get to right here on the calculator for me, I don't get all that frequency list calculate. That's not there for me.
So you probably don't have updated software, so you probably can't use this. The thing is it doesn't show up on my other screen. I don't think, I'm gonna look at do you have a TI 84, Rashad?
Yes.
Okay, so you probably don't have updated software, either that or I wonder if there's a way for you to like, if maybe we can Google it. I can probably look it up, see if there's a way. And I'm trying to
Yeah,
see
like
if I can do comma.
that's those words aren't there, but when I did when I pressed 2 enter, it does say L2 after the 1 dash bar stats.
Okay. And did it work? Did you get the same numbers I did?
Yes.
Okay, so maybe
No.
that's what you need. No. Okay. So
No, I did not.
something wonky happened. So let me look into it. I'm going to write
Okay.
a note to myself. This is why I keep a post-it note. I keep a post-it note right next to my computer, but I don't have a pen for some reason.
So after all, when I compute it or calculate it, after all of my numbers, it has an E0, E1 at the end of like each one of these figures.
Oh, that's weird. No frequency list. Okay, so what I'm going to do is I'm going to look that up, and I'm also going to, okay, wait. It says, did you see that in the note, in the chat? It says, Katie says to do L1 comma L2. Try that.
Oh, where is that?
So in your
Oh.
list, so when you go to that screen, try L1 comma L2. So when you're here, when you're in your list, you would do L1. Now it's not gonna work for me because I have the different thing, but she says like this, so it should look like, whoops, I didn't do the comma. It's not gonna allow me to put a comma in there. But do in that list, do L1 comma L2 and see if that works.
I just got lost. I don't even know what's going on.
So up here, so does it say list on your first thing?
No.
What does it say?
I just went I have to put all the numbers back in now and like
Okay.
do the whole thing over.
Okay. I'm gonna real quick, let me do on my TI 83 and I will write down what I need to do. Just a second here. I'm gonna real quick put it in my TI 83 and see if it works. And then if it does, then I will just write it out. Stat. Okay, L1, comma, L2. Okay, that works. Okay, I'm gonna go to my other screen and I will show you. So when I'm on my TI 83, it just, let me see here. Here's my lovely screen. So on my TI 83, it just shows up like this. Let me see. It just shows one var stats on my screen. That's really ugly. And this is not a good screen. Let's try this again. Let's get rid of the box. Okay. So it just shows one var stats when I go to that screen with my TI 83. So then put in L1. So that's second one, then put a comma, and then put L2. This is what it's going to look like on your screen. And then when you hit enter, then it should calculate that for you. Thank you, Katie. You rock. Now, if you forget to put something in the L2 column, it's going to give you a dimension mismatch thing. Katie, if you were in person, I would give you a smelly sticker right now. It's awesome. All right. That was all I have for you today. Y'all are rock. This is probably the latest the class will ever go, but I really appreciate you coming for a double dose of math tonight so that I can do parent teacher conferences Thursday. I would much rather hang out with you guys than go to parent teacher conferences for sure. But y'all rock stars. Thank you so much. I'm going to quit sharing my screen. Are there any questions for the, I'm going to not quit sharing my screen just in case. Any questions while we're still recording?
I have one more question.
Okay.
If you were, because I have opened up some of the homework questions, if you were to just give us, let's say, the mean, and then we use the empirical rule, like the percentages,
Mhm.
whatever that bell-shaped thing is called, I forgot. So if we go by percentage, are we able to find, if you just give us the mean, are we able to find the values in the next standard deviations?
You need the standard deviation unless, hold on. So if I gave you the, like, for example, let me go back a little bit. So example here, I'm going to erase all of this because there's a whole lot of stuff. Whoops, that's the wrong box.
I guess I just get confused about the percentage. Like,
Okay.
yeah.
So like, for example, on this one right here, I can look at this and I can see that this right here is the mean. And if I
Mhm.
took 69.1 and I subtracted 57.4 from it, I would get the standard deviation. Is that what you're
Okay.
saying?
I
No.
don't know. I just am confused about the 34%
Okay.
part. So is like
So this
69.1
right
to
here,
57.4, is that like 34% of
yeah, so
the?
68% of my data is within one standard deviation of the mean. So this
Okay.
box right here, 68% of my data is inside that box. So it's
Okay.
34 below the mean and 34 above the mean.
Okay.
And then this box right here has 95% of my data. So it includes that 68% plus 13.5% below and 13.5% above.
Mm-hmm.
And then this right here, this is 99.7%. So it includes the 95% plus another 2.35% above and below.
Okay.
And then this is what's left over outside of 3 standard deviations.
Got it.
Okay. Hopefully once you start doing your homework and all of that, hopefully it'll sink in. So just try to do some examples. If you have questions, you know where to find me. Did that answer your question?
Yeah, I think I just was making it more complicated for myself than need to be.
I do that all the time. Any more questions while we're still recording? All
I
right.
have a question.
Okay, go ahead.
On the question number 1 from the homework, you had put in all those values into your computer or into your calculator,
Yes.
and then you were looking at getting the frequency on the T184. Is there a way to show? So I did it on the T183 and I was able to get frequency.
Uh-huh.
But it has like the standard deviation and all of those alphanumeric things, and it has numbers after it. Can you show me on the T184 calculator that you have on your screen which one of those numbers actually is like the frequency that, or whatever it is that you were originally looking for?
Okay, we're just looking at the question here asks for the mean score and the median score. So the mean score would be your X bar. So it'd be 6.43 on mine, or 6.4. And the median, I'd have to scroll down a little bit. The median is MED and it would be 6.
Okay, I got that same thing on mine. I just wanted to make
Hi,
sure
Megan.
I had done it correctly.
Yes. All right.
Awesome, thank you.
You're welcome. Okay. I'm gonna turn off the recording